Hello and welcome to Aerospace Mechanical Engineering Lab 1. Today we are going to discuss the tensile test. So in order to do the tensile test, we need dog bone samples. You will be given a plastic dog bone sample, a composite dog bone sample, and aluminum dog bone sample based on the availability, of course. 2 aluminum dog bone samples, annealed and T6, meaning the heated and strain hardened. And our goal would be to do a tensile test using the Exceed machine that we have right here. And eventually what we want from you is to calculate the modulus of elasticity based on sigma, epsilon, the stress strain curve, and give us the ultimate stress and also where the fraction happens. So at the end of this lab, you will need to give us, again, the modulus of elasticity for each of these samples, epsilon, sigma stress strain curve, and the ultimate stress and the fracture stress. Okay, so we essentially need to learn how to set this up, how to put these samples in, and how to run the test using the computer that comes with it. Okay, to set your dog bone sample up, you need to make sure that the device is turned on. There is a turn on knob right here that you can use, and there is a handheld control that you can use to move the head up and down, right? And you want to make sure you locate it in a way that these 2 parts of the dog bone sample are standing at the end of your fixture. So this head right now has to go up a little bit. In order to work with this handheld control, you have to make sure to unlock it first, and then we can move it up. The green button has to be on. We can move this up as much as we want. A little higher will actually, so this fits in right now. We can stop right here. We can put the control back in its place. And the next step would be to tighten the fixtures. There are 2 screws on top and the bottom we can use to tighten the fixture. You want to make sure to hold on to the fixture itself because we don't want to add any torque to our sample, right? Okay. Again, hold on to it because we don't want to have any angular displacement, any torsion. As long as it is tight enough, we have what we need. And the next step would be to calculate the strain, essentially to set up the strain calculation mechanism. So to set up the strain calculation mechanism, there are 2 things we can do. We can actually track the movement of the head, but the tracking the movement of the head is not the most accurate thing to do because that might include the slippage of the fixture. So what we do is we use an extensometer. Its job is to track the extension of your sample, dog bone sample. We can also use a strain gauge, but we want to use the extensometer to learn how extensometers work. There are 2, you just have to make sure you actually put it on your sample like this. You want to put it on your sample like this, and then you want to make sure to actually use the grips. Okay, so this is set up, and we are ready to run the test. You just have to do the test for different samples. Right now I'm doing it for the composite test, but you will do it for an aluminum test and maybe a plastic, aluminum sample and a plastic as well. So to set up the test, we need to use the TW Elite software right here. Double click, it will ask you for a username and password. The username and password is on the table. You can just read it off the table, but it is ME Lab. So you will log in, and then when the software opens up, the controller, the handheld controller, automatically locks, and we will be ready to run the test from here. So you just have to go to the templates, EM, and we give you a lot of different templates. The template we want to use is called the MTS EM tension using the extensometer, or we can use the extensometer crosshead. We can actually have both. I'm going to use the extensometer for now. So the first thing it asks is the width of your dog bone sample and the thickness of your dog bone sample. These are the things you need to measure with a caliper. I'm going to go with the default values now, but again, you need to make sure to do measurements for this. And then the extensometer gauge length, this is a 2-inch extensometer gauge, and the test rate and the data acquisition rate are the things you don't really need to change. Okay. Before running the test, you see the loads, it says 76 newtons. We need to zero this out. So you right click on this panel and zero signal. The same is true for the crosshead, signal, zero signal, and the extensometer signal. So the signal is 0. At this point, if you have the correct values here, you are ready to run the test. So if you just click run, it will start running the test. Okay, we are ready to run the test. We wanted to make sure to change the shot so you can actually see how the test progresses and how the breakage happens. But as soon as you run the test on the monitor, you will see the stress versus strain curve, or actually deformation versus, or displacement versus load. So this later needs to be converted to a stress versus a strain. So I'm just going to click run, and you're going to see the movement of crosshead in just a second. It's asking me to reset the inner lock. This is the reset inner lock button. It's pretty simple. Just have to make sure to reset it, and I just did it. And run the test again. It will ask me about the width and thickness, just to make sure we have the correct width and thickness. When you hit OK, the test will start running. I'm not sure if you see the if you saw the movement of the dog bone sample, but it is a composite panel, so we don't really have a huge plastic region, and we were all in the elastic region. When you are done with the test, I'm going to show you how it looks like. So if you look here, the breakage happened here, right here. So again, this is a composite panel. We don't really see a huge plastic region. It was all the linear region. I'm going to remove my extensometer. So you do not really click anything on the computer. It is asking me on the computer to return to 0. I'm not going to return to 0. I'm not going to click anything. I'm going to remove my sample first. As you can see, it is cut from right here. Again, it is a composite panel. You don't really see any necking. It was just a very clean break. So next step is to look at the software again. So this is what you will see on the monitor when the test finishes. This is our load versus extension in inches and in pounds of force. As you can see, this is just a line, and then it went back as soon as the breakage happened. The reason we only see a line is because we tested a composite. So the plastic region is basically non-existent. It's asking me whether I want to return to 0. If I click yes, it will start moving the crosshead to this original location. I'm going to click no so I can adjust the crosshead myself later on. When I click no, it will give me the charts, right? This is my chart. The red one, this is my load versus extension. and it has actually calculated a modulus for me itself, right? But this is not a value we are going to use. What we are going to do is we are going to export the data that we have, the raw data specifically, and we only need the load versus extensometer data, which is the things that we do have here. And we essentially just need to export it. It needs to be in a correct folder. I'm going to use the desktop right here. It is asking me whether it needs to create a new folder. Yes. The type of formatting, delimited text. This is the text that you can use later on. And the unit we can change to inches, pound, force. We can also change to millimeters and newtons if you want. I'm going to keep it as is and then click export. Data was successfully exported to desktop. We have our data. We have a lot of test runs here. So I'm just going to open one of them. So essentially, we'll be given the same data. This is a clean data. If you will, we have the crosshead, load, time, extensometer. What you do is you take the load, you take the extensometer, you convert this, the extension in inches, you convert this to a stress and a strain, create the stress strain curve, and from that curve, find the ultimate stress, find the fracture or rupture stress, and find the modulus of elasticity. And that will be it for today's lab.